So I'm going to do the last few problems here from the last page of section 6.1. So what I want you to see in the next example that we have here is that this is asking us for the opposite of what we just found. So we've been looking at z-scores and we're asked to find the area associated. Now with a question like this, it's actually giving us an aspect of the area. So when it says 15th percentile, it's actually relating 15th percentile would be 0.15 in terms of an amount of area. And what we really want to think about here is when we're looking at our normal distribution from the negative values to the positive values, we know that 0.5 or 50% would take us from the left-hand side up to the middle. So when we're talking about 0.15 or the 15th percentile, that's actually a quite low percentile and sends us to the left side of the normal distribution. So if you kind of remember the empirical rule, it would give you an idea of how much, but I don't really test much on where you put the line as long as it's kind of reasonable. But you just want to include essentially 15% or 0.15 of the area in your picture. And then the idea here is you're actually trying to figure out what value this is, what z-score that is. So your job is to find the idea behind the percentile, the 15th percentile, and your job is to find the associated z-score. Associated z-score. So what we do in this case is we do the opposite in terms of the table. So I'll show the table and then I'll show it on the calculator, or I'll talk about it on the calculator. And what we're going to do is we're going to go inside the table, into the middle of the table, and we're going to look for where is the value that is closest to 0.15, and then we can basically go like this to see what z-score that is. So I'm going to head to the tables, and we take a look here. Okay, so it's going to be here. These are negative z-scores because notice we are on the negative side of the standard normal distribution. But the idea is you want to look in the table and you're going to find the number that is as close as possible to 0.15. And if I look here, I have 0.1492, and over here I have 0.1515. And if you subtract both of those from 0.15, you actually find that this value is a smaller distance away. So it doesn't matter, it's just whichever number is closer. So this is closer to 0.15 than this other value here. So what that tells us is look for the associated z-score. So that's a negative 1.04. So that is the z-score associated with an area that is, in this case, due to the table, as close as possible to 0.15. This table does not have every single possible amount of area because it's going to only 2 decimal places on the z-score. So we're going to take that number, negative 1.04, and that's actually, so let me put a note here. So the closest area is 0.1492, but the value that we found, the z-score, is negative 1.04. Now, doing this on the calculator, I'll flip back to a value, the directions, right here. So here we're finding a z-score. And what we just did was we used the table. So we look up the z-score associated with the area that lies to the left. So that was negative 1.04. It has an area of 0.15, the value we found closest to possible, area to the left. Now there's another way to do it, and it's using the graphing calculator. So you're going to go to the same place where we saw binom PDF and binom CDF. We're now getting into this idea of distributions. So you're going to go second VARS, and that's going to take you to the distributions. And you're going to use a function called inverse norm. Okay. So let me head back. So The z-score that we want is using INV norm. Okay. And then the idea is if you get out your calculator and you do it, so you press second VARS and that takes you to distribution, you'll see number 3 is INV norm. And if you click on it, so everybody should be doing that, you're going to put in 0.15 because that's our amount of area that we shaded. Your mu and your standard deviation, your sigma, should probably already be defaulted to 0 and 1 because you're in a standard normal distribution. That's how it defaults. And we can change that in other sections. And then you just want to say, where is that area located? Is it to the left of something? Is it to the right of something? Or is it in the center? And looking at our picture there, we have the tail is on the left. So we choose left, and then we press paste. And then we press enter. And what you should see when you do that, and so what I'm going to do first here is I'm going to put in 0.15, 0, 1, and left. So notice that's what comes up on your screen. So that's what I'd want to see so I know what you used. And that's negative 1.0364, you know, it has multiple decimal places. So to 2 decimal places, which is always your z-scores, negative 0.14. So we get the same answer in the table as well. Every once in a while you might be off by like 100th just because the table is finite in terms of the values that it gives you. But, and so the calculator is, you know, a bit more accurate at times, but, you know, in this case it's exactly the same. Okay. So now we're flipping back. Now it wants a probability given a z-score. So I'm going to use the calculator on this one. You should definitely always be thinking about what you can do when you start, which is always labeling your normal distribution and shading correctly. So you can pause this and do your shading. So here we have negative 0.55. So it's between 0 and negative 1. And that's what you're thinking about. Where is that negative 0.55? This is a z-score. This is never going to be an area because it's not even positive. So it's got to be a z-score. And in this situation, I'm going to use the calculator function to show this because you can look this up in the table and you can find the area associated. Or you can use your calculator. So I'm going to use the calculator. Now in the calculator, let me go back and show it. Okay. In the calculator, the way to find area is same place. We're just there now. So second VARS, that's going to take you to your distributions, but we're going to use normal CDF, and that's because we have a normal distribution, and C is cumulative because we are adding up a bunch of different probabilities here from, you know, some region that we're shading. But what goes inside is your lower bound, your upper bound, your mean, and your standard deviation. And I'll talk about lower bound and upper bound because the mean and the standard deviation we've already been talking about, 0 and 1. That's no different. So it's really just lower and upper that goes into normal. Okay. So now in here, what you're going to see is we are going all the way out here, all the way. So it's all the way up until negative 0.55. But technically, this goes on forever. Okay. So I'm going to put the function I'm going to use, normal CDF. And what I want you to understand is this lower bound, you would not put negative 3 because technically this goes farther. And these normal distributions, they actually never touch the horizontal axis, but even though they get infinitely close. So I want you to think about that like kind of in terms of the thing that I showed in part 1 with the coronavirus. Even though we have like certain values that we're talking about from here to here, if you think about the coronavirus, there will probably be a smattering of people that get it in the future. Hopefully that's never some high amount. But the idea is in order to grab all the area, when the area never actually touches the ground, because the frequency could be very, very low in any situation. So the probability would be very, very low. We've got to grab it all. So although it might sound really weird, in our calculator, typically we put a very large negative number. And I typically tell students that they can choose negative, 1, 0, 0, 0, 0, 0, something very, very big. Now, in a case of the standard normal distribution, you wouldn't even need to get that big and you'd be able to grab everything. But if, say, we were talking about weights of cars and our middle value was 0, our middle value was, say, average weight of cars, I don't know, 2,000 pounds. I'm not sure how much cars weigh. If we go in with our standard deviation, we could actually end up with pretty large numbers along the bottom. So by picking something like negative 100,000, notice I do not put a comma there, no comma. That's going to help me. And then that's going to go up to 0.55, and then we have 0 and 1. So what I want you to do is with your calculator, and I'll do it with you, you're going to go second, VARS, and then choose normal CDF. We are never going to use normal PDF. Telling you right now, never going to use normal PDF. Only normal CDF. Okay, so we're going to click it. And notice it says lower. And if your calculator is like mine, it gives this default, -1 times 10 to the 99. That is that's a negative number that is way, way, way small on the number line. I mean, it's negative, -1 times 10, 99 times. I mean, that is crazy, crazy small because it's this large negative number. So you can just leave that if you want, because you don't have to put in the number that I put in, because that's going to be fine. And then you put in -0.55, and then your mean and standard deviation, at least on mine, is already defaulted. So now we're just going to press enter, and our answer just pops up. It's just right there. So now I'm going to round that to 3 significant figures. So see if you get the same thing. 0.291. So that's the area to 3 significant figures. And that's your answer. And so what the calculator is doing is it's adding up all the area from negative, this -1 times 10 to the 99, all the way up to -0.55. Now, when it asks this question down at the bottom, would P, and then Z is less than or equal to -0.55 differ from A? It would not. And the key thing here for this in chapter 4 and 5 with discrete probability issues is that we're not worrying about any one value. So the idea here is that P of X equaling 0.55 is actually 0. So the probability of, and I should actually have a negative on that. The probability of any specific one value for a z-score is 0 because the data is continuous. And so that's why we look at these shaded regions, because we're actually trying to take a chunk of time with the continuous data. The data for any one value is basically 0. So you will never see the equal to sign. Okay, let's do a couple more things. So find the z-scores that separate the top 10% and bottom 10% of all values. So I'm going to start off like I always do. Great. Now, what I'm going to do is I'm trying to find 2 z-scores. So I'm just going to go ahead and use the calculator here, because for anything that requires 2 values, whether it's finding what z-scores relate to what probabilities, which is the situation we have here, or something else, the calculator is really the best way to go, and typically that's what I'll let you use. So remember, the idea here is thinking about where are these values going to sit. And if you're going to talk about the bottom 10%, you're down here somewhere. And if you're talking about the top 10%, you're talking about something over here. Yeah. And your job is to find what is this value and what is this value. And one key thing to see is they're symmetric, because the normal distribution is symmetric. And so if you're talking about the same percentage on each side, which is 0.10, 0.10, well, those are going to be the same. One of them is just going to be negative and one's going to be positive. So I'm going to use inverse norm because I'm given area and I need to find values. Now in the calculator, you can do this a couple different ways, but the idea is the easiest way would be to think about if this whole thing is 1, then if you have 10% on one side and 10% on the other side, how much is left in the middle? So if you do 1 minus 0.1 and 0.1, you get 0.8. So the easiest way to do this, it would give you everything you need, would be to put in the calculator 0.8, same mean, same standard deviation, but then instead of using left or right, say, well, the area is in the center. And what that's going to do is it's going to give you the two values that you want here and here, because it recognizes that you're talking about the center of data. So you can go ahead and go to the distribution, go to inverse norm, and then put in that 0.8, put in the mean, the standard deviation, but then choose center. And when you choose center and paste it and then press enter, what you want to see is that it gives you two values. And it tells you that one of the values is a negative 1.28. The other value is 1.28. So like I said, they were going to be the same. So you have two z-scores, one for each side, negative 1.28 and 1.28. And those separate the top 10% and the bottom 10%. So they give that line of where the 10% sits on either side. And so that would be the answer for that one, another inverse norm. And the last thing that I'll mention is when you talk about z alpha, it's called a critical value. We're going to use it more in chapter 7 and beyond, but I'm just going to bring it up now. Z sub alpha, so that's sub because it's little, and that's an alpha, little Greek letter alpha. It's called a critical value. It's a special z-score. And it's a z-score that has an area of that much, whatever alpha is. So like in this case, it's an area of 0.05, but that is to the right, to the right. So when you think about it, this is kind of the opposite of some of the other problems we did. So we're seeing another example, but the idea here is there is some value here for which you have 0.05 area to the right of it. So our job is basically finding this. No different, no different, still the same, always the same, 2, 3. So our job is just to find, and we already know that it's between 1 and 2, and I'm kind of using the empirical rule here. I am using the empirical rule because I know how much area sits in these spaces depending on how many standard deviations. So in a case like this, I'm going to use the calculator, and I'm going to use inverse norm because anytime I need some value from a z-score, inverse norm is really the way to go. So our area is the 0.05 mean. Standard deviation, no different. Always just for standard normal distribution, this is what it is. But in this case, we are going to the right because whatever this score is, that little area in the tail is to the right. So what you can do now is you can go into your calculator and see if you can get that answer. See if you can put it in and make sure that it works. I'm going to move a little bit because I know where I'm going to try to put my face. So there we go. So I'm just going to put it over here just to make sure that I have space for my picture. So we go into the calculator and we go distributions, inverse norm, and we're going to put in our area of 0.05, mean, standard deviation, but I'm going to click on right, and then I'm going to paste. And when I paste, I'm going to get to 2 decimal places. That's always how we round z-scores, 1.64. So I'm going to come back here, and what I want to do is just mention how you could do this on the calculator. So I want to show a couple more examples. These are just go back in your notes here. But you can use normal CDF here just like we just did. So you can go -1 if you want to use the way your calculator uses it, there, all the way up to 1.35, and then you're just going to go 0 and 1 for mean and standard deviation, and that should give you the same answer that we see for A that we did using the table. Now for the second one, this is kind of a different example here. You would use normal CDF. What normal CDF is going to do is it's always going to add up whatever area between the two values that you put in. So in this case, we wanted this area over here, which started here and ended infinitely far away. So we're starting in this case at 0.68, and then we're going up forever. So instead of using negative, you could use positive like this, and your E button, that button that you'd want, actually is a little confusing because it's a double E, but it's above the comma. So if you use the blue button, you can get that E, it's above the comma, and you can put this in, which again just indicates something very, very large, and then 0, 1, and you're going to get the same answer that you got from above. And then last thing, to do this one on the calculator, which is typically how I would test, would be to allow this on the calculator because it is a lot. I'm going to have, and make sure when you're putting in this stuff, you let the calculator do the commas because you don't want to put commas in or it'll read it kind of funny, just as a tip. Okay, so we have -2.43 to 0.88. So this is really nice in the calculator because we can just go normal CDF, and then we have our lower bound. That's the smallest value that we're starting from. And then 0.88, that's the largest z-score that we're ending at, and then 0, 1. And if we do that, again, we're going to get that same answer that we got from above, but we're going to get it in that one step. And so we don't have to think about any very, very large number or very, very small number because our bounds are within the normal distribution. Very easy to see. So the calculator is helpful in that way. So 6.1 is a lot. Thank you for sticking with it. We will talk about this in class, and so think about any questions, put them on the discussion board, and hopefully we can all help each other to understand.